Hello, welcome back to Ken O'Connor Racing. What I have here is a 1999 excuse me, Suzuki RM 250 crankshaft with a brand new Pro X connecting rod. Anybody that follows these videos, they know I've shot a bunch of crankshaft videos, but somebody sent me an email the other day and it was kind of interesting. They said, you know, Ken, you've shot videos for CRs and blasters and some RM125s. He said, but what about my bike? I've got, you know, a different type of bike, and I had a hard time finding you on YouTube. So he made a suggestion that we just shoot crankshaft videos for every single different model that comes in here, and it'd be more accessible on YouTube. And I thought it was a good idea. So if you've watched a bunch of these crankshaft rebuilding videos, you can go ahead and shut this off and save yourself a bunch of time. If you are interested in seeing how we do an RM250 and you haven't seen one of these videos, I'm sure you might pick up a couple of pointers, but we'll get started on this thing. Here's the problem. Alright, let's clear up a myth before we even get started. See this dark spot here, overheated? That's from this crank being assembled at the factory, or an aftermarket place even. We don't use heat, but I mean some places do, and it's totally acceptable. We just have other ways of doing it. We don't need to use heat. But this does not indicate that these webs are bad. This was done at the factory, and what they do is they heat this web up and then push the other pin of the crankshaft into it. It just makes for easier alignment of the crankshaft. So if you see something like this, and you're probably gonna, on any crank that you get in your hands, that's perfectly fine. This particular crankshaft uses aluminum stuffer blocks, and the crank gets kind of thin in here. For that reason, a lot of shops do it like this, and I guess it's fine. We chose not to, but what they do is they'll put a separator plate in here, drive on this pin, and get these webs pulled apart. We're not going to do that. We don't do that to any cranks anymore. We find that there's a lot less distortion if we cut it. So we have a proprietary machine. I'm not going to show it to you, but what we do is we hold that rod, and we're just gonna cut right here, right through this pin, and that's going to separate our webs. At that point, we can support inside directly around the pin, drive the two halves out, and create no additional distortion in the crankshaft. I just feel it's a lot more accurate job, and a lot of other, you know, top of the line builders do it the same way. So that's the first step, get that rod cut in half. Okay, here's what it looks like when we get it out of the machine. And again, we just cut the pin, and if you weren't following or you didn't understand the whole reasoning behind this, I'm going to be able to support the crankshaft web here and then drive the pin here. Zero chance for distortion. My other option was to support around here. A lot of force taking a crankshaft apart, and we don't want to risk anything. This isn't our stuff, this is yours. We're going to take good care of it. So rather than support out here, I completely prefer to support it right here, and then we're just going to drive both of these pins out on the 40-ton hydroelectric press. Got my pins pressed out, and the web's clean. Next thing I'm going to do is, just as a safety precaution, I've never seen it happen, but we don't take chances in here. I'm going to check these little Allen head bolts that hold the stuffers into the webs. I'm just going to make sure nothing's loose. Here's the components you get with a Pro X connecting rod kit. You get both thrust washers, big end bearing, connecting rod, the pin, and the top end bearing. Something to think about. You send an engine out for a rebuild, and you have a crank rebuilt, and they charge you for that crankshaft rebuild, and then they charge you for a top end bearing on top of it. Unless it's OEM, every kit out there comes with a top end bearing. So ask them why you're getting charged for a top end bearing if you had your crank rebuilt. Next thing I'm going to do is clean these parts up, wash my hands, and get the pin into the drive side of the web. Alright, here's a shot with the pin pressed into the web, and this was actually flush in here. It's pretty easy to put in. When you drive that pin in, just make sure it's square. What I like to do is just put initial pressure on the pin and then release the pressure immediately. Come back down, hit it with some more pressure, release it, come back down. They'll usually go right in there nice and straight. Next thing I'm going to do is get the thrust washers, connecting rod, big end bearing on that web. No rocket science here. Don't force anything. Now we're going to take it back to the press, put it in our jig, and get this thing pressed together. Alright, here we are with our crankshaft jig, and what we're doing here is this is the bottom web that the pin wasn't pressed into. These two plates, the center hole in relationship to the Thompson shafting here, everything is perfectly lined up. So by putting this web in the bottom and then the other web that we pressed the pin into in the top, and then just spinning it, lining it up, this has no choice but to go together perfect. So next up, we're just going to fire up the press and press this thing together a little bit. Stop right there and do the rest of the assembly outside of the jig. And I got my final assembly done. I get my width here where I want it and get the web set. And I'm showing on the left maybe a 1/10. Indicator on the right, about 5/10. So this crank's well within spec. Thanks for watching. KennelFounderRacing.com.